Hello everyone, I am Aftabala, Maths faculty in Motion Education. So today we are going to discuss basic maths. Okay. So what is the first point here? The first point is root is a positive quantity. Root is a positive quantity. Root is a positive quantity. Okay, so why, the question is that why root is a positive quantity? So it's very simple reason. We know that root under negative is not defined, means if you put anything which is negative under this root, so it will become imaginary. Okay, now that's why it is a positive quantity. Now second point is point number 2. Point number 2, root under f of x exists only when this function f of x is greater than equal to 0. Okay, greater than equal to 0. What is the meaning of this? Means root under any function, root under f of x. Okay, this function exists only when f of x, means this function should be greater than equal to 0, means non-negative. Okay, so first of all I will discuss what is the basic difference between positive, negative, okay, or you can say non-negative and non-positive. Now see this here. We know that this is a number line. Okay, now this is a 0 here. So we know that 0 is a neutral number, that is neither positive nor negative. Okay, now we know that from this 0, if you move towards the right side, then you will get positive number 1, 2, 3 and so on. Now in the same way, if you move towards the left side, then you will get negative number, minus 1, minus 2, minus 3 and so on. Now see this here. What is called positive number? Any number which is just greater than 0, that is called positive number. What is called negative number? Any number which is just less than 0, that is called negative number. So see this here. This number from 1 to this one, all the numbers is positive. Why? Because this is greater than 0, 1, 2, 3 and so on. In the same way, this number is negative. Why? Because this is less than 0. This is negative, this is positive and this is negative. Now the thing is that how to identify non-negative and non-positive, means what is the main difference between non-negative and non-positive. So see this here. If you include this 0, in this positive, so it will become non-negative. This is non-negative number. Okay, if you include this 0 in this negative, so it will become non-positive. Non-positive. Okay, so this is the basic difference between non-negative and non-positive. Any number which is just greater than 0, positive, which is just less than 0, negative. If you include this 0 in this negative, so it will become non-positive. If you include this 0 in this positive number, then it will become non-negative. Okay, so I hope you are getting this. Now I am asking a question here. What is the value of this? Example here, root under 4. What is the value of this? Plus 2 or minus 2. So if you are saying this minus 2, so you are wrong. Minus 2 is not possible. Okay, this is incorrect here. Now, so what is the value of root 4 is? Plus 2. This is correct answer. How? See this here. Actually, this according to the definition of maths, means root under any non-negative quantity is always non-negative, means root under non-negative quantity is non-negative. See this here, this 4 is a non-negative, non-negative means positive, so this one we are getting non-negative. Okay, in the same way, but how it is, I can prove. See this here. Suppose here, if you are putting, I am asking here, root under x square equals to, root under x square equals to, you can't say x. If you are saying this x, so it is wrong. So what is the value of root under x square? Why x is not possible? Because we don't know the nature of x. That's why root under x square equals to, you can't write root under x square equals to x. So what is the value of this? Mod of x. Mod of x. Okay, how? See this here. So put here x equals to minus 2. Put x equals to minus 2. So root under minus 2 whole square here, and here what you will get? Plus mod of 2. Mod of minus 2. Root under minus 2 whole square, we know that 4. So you will get here 4. Here what you will get? Right side. Right side you will get mod of minus 2 plus 2. So we are getting here plus 2. Okay, LHS, root under minus 4. So root under 4 equals to 2 plus 2, and here we are getting plus 2. So see this LHS and RHS same. But if you are writing mod root under x square equals to x here, so what we will get here? Minus 2 only. So LHS will be 2 and here minus 2. Okay, so LHS RHS will not same. It means this means whatever we are going to consider this x, so it will be wrong. Like this, see this here. Root under x square equals to, if you are considering x, according to you, if this is x, so if you put here root minus 2, so minus 2 whole square equals to here minus 2. So what you will get here? Root under 4 equals to minus 2. Here you will get here positive number, because we know that a square root of any non-negative quantity is always non-negative. So here plus 2, here minus 2. See this LHS RHS is not same. That's why this is wrong. You can't write root under x square equals to x. You should write what? Mod of x. Okay, so root under 4 equals to plus 2, not minus 2. Now what is the second point? Second point is second example I am taking in this. See this here. Root under x square equals to 4. So what is the value of this? If you are saying root under 4 equals to plus 2, not minus 2, so what is the value of this? Root under x square equals to 4. So value of this is plus minus 2. See this here, how? X square, and one more thing, this is a quadratic equation. We know that power of x is here 2, so this is quadratic equation, and we know that if according to the highest power we will decide the roots of the equation. Here what is the highest power of x here? 2. So how many roots possible? 2 roots possible. Okay, now see this here. X square, this one 4 I am taking left side, so equals to 4. X square minus 4 equals to 0. Now we know that a square minus b square equals to a minus b into a plus b. So I am writing here a minus b into a plus b. Okay, you can write in this way, na? X square minus 2 square. Okay, and we know that this one a square minus b square, you can write a minus b into a plus b equals to 0. So product of two things is equals to 0. It means this should be 0 or this should be 0, or both can be 0. So here you will get here x minus 2 equals to 0. So you will get here x equals to 2. Okay, if you put this one equals to 0, so you will get x plus 2 equals to 0, then you will get x equals to minus 2. Okay, so what we are getting? We are getting x equals to 2 or minus 2. Okay, so our next heading is x square, x raised to the power 4, x raised to the power 6, x raised to the power 8. In this way, x raised to the power 2n is always non-negative. Again it is coming non-negative. What is the meaning of non-negative? I have already explained. Non-negative means, what is the meaning of non-negative here? See this. Non-negative means greater than equal to 0. Means in positive number, if you are including 0, then it will become non-negative. Okay, so this is non-negative. Why this is non-negative? So you can say in a simple word in this way: x raised to the power even power is always greater than equal to 0, means non-negative. How? See this here. I am taking, suppose here any example here I am taking x. I am taking here example x square I am taking here. Okay, now see this here. If I am taking x square, so if put here instead of x, put any number which is just greater than 0 or less than 0, any number which is negative or either positive or negative. So suppose I am putting minus 2, so minus 2 square 4. Put here any number which is greater than 0, means 2 I am putting, so 2 square we are getting 4. Put 0, so 0 square we are getting 0. Means either we are putting here negative or positive or 0, we are getting what? All number are positive. See this here, we are getting positive, greater than 0, greater than 0. Okay, so and this one is 0 we are getting. So we can say x raised to the power even power is non-negative quantity. Okay, so our next point is exponential function is always positive. Exponential function is always positive. How? See this here. Next point is exponential function. Exponential function is always positive. exponential function is always positive. That is, you can say 2 raised to the power x, 3 raised to the power x, 4 raised to the power x, in this way. Okay, in this way these are always positive. So what is the meaning of this positive? I have already explained. Positive means greater than 0 only. Non-negative is greater than equal to 0. Positive means greater than 0. Okay, means you can say in a simple word, I am taking this one here. So 2 raised to the power x is greater than 0, or you can say a raised to the power x is greater than 0. So and you can say e raised to the power x is greater than 0, means exponential function is always positive, greater than 0. Okay, so now see this here. Suppose I am taking any example. In the last step of any question, last step of any question, in the last step of any question is in this way, like 2 raised to the power x equals to minus 1, 2 raised to the power x equals to here 1, and 2 raised to the power x equals to 0. Then what is the value of this? See this, it's very simple. 2 raised to the power x equals to minus 1. So we know that this is exponential function and this is always greater than 0. How? See this, na? 2 raised to the power x, put instead of x 0. If you are putting here 0, suppose you are putting here instead of x 0. Okay, so 2 raised to the power 0, we know that this 2 raised anything raised to the power 0 1. So 2 raised to the power 0 1, this is greater than 0. Yes, so this is satisfying. Okay, same put any negative number instead of x. Okay, so I am putting here 2 raised to the power minus 2 is greater than 0 or not? Yes, this is greater than 0. How? See this here, 1 by 4 is greater than 0. Yes, so it is also positive. Okay, now third, put here any positive value. So we know that it will be positive always. So 2 raised to the power, suppose I am going to put here 2, so which is greater than 0. So here you will get 4 is greater than 0. Okay, means either we are substituting here positive, negative or 0, we are getting always greater than 0, means positive we are getting. Now see this here, this 2 raised to the power x in the last step of any question, suppose we are getting 2 raised to the power x equals to minus 1. So what will be the value? See this here, this is LHS, this one is LHS, and LHS is greater than 0, means positive, because exponential function is always positive. And this one is RHS is negative number, this RHS is negative, this RHS is negative. So see, this LHS is positive and RHS is negative. Not possible. Why not possible? LHS RHS not satisfying. Okay, this one is not possible. Now see this here, second, 2 raised to the power x equals 2 raised to the power x equals to 1. Okay, so what we will do here? Simple. See this here, 2 raised to the power x equals to 2 raised to the power x equals to 1. So what can I write? I can write in this way 2 raised to the power x equals to here 1. 1 is there. Can I write in this way 2 raised to the power 0? Why 2 raised to the power 0 I can write? Because here you can say 1 we can write in this way also, 3 raised to the power 0, 4 raised to the power 0 we can write. Yes, we can write, but actually the thing is that here base is same. So we know that for comparing the power, base should be always same. So here 2 base is already 2, I have means it is given. So we need to take here 2 raised to the power 0. Now base is same, so we can compare power. So what is the value of x? X will be here 0. Okay, next see this here, 2 raised to the power x equals to 0. So we know that this one also here 2 raised to x is, this one is LHS is greater than 0, because exponential function is always greater than 0. Here we have already studied this one, exponential function is always greater than 0. Okay, so this quantity LHS is greater than 0 and this one is equal to 0. So this is equal to 0. So how it is possible? Not possible, because this LHS is positive, this one is 0 only, so never possible. Also this one is also not possible. Okay, so in the same way, I hope you are getting this. Means this one and this one. What is the difference between this one? Means LHS is positive, RHS is negative, not possible. Or here LHS is positive and RHS is only 0. Okay, so equal value is given. So this is also not possible. Here LHS is exponential and this one is positive and this one is also positive. Yes, possible, because LHS is here greater than 0, RHS is also greater than 0. Then we can compare. Okay, now our next heading is mod of x Our next heading is so our next point is mod of x. Mod of x is always positive, always non-negative. How see this here? Mod of x, that is, you can say that is mod of x greater than equal to 0. Simple. This modulus of x is also non-negative. I have already explained non-negative means greater than equal to 0. Okay, so this is also non-negative. How see this here? Suppose I am going to put here instead of x 2. So what is the mod of 2 value? 2. If I am asking mod of minus 2, so plus 2. If I am asking 0, so we are getting 0. See this here, either we are putting negative or positive, we are getting positive value. Okay, when we are putting 0, so we are getting 0, means this quantity is non-negative. Mod of x is non-negative quantity. Non-negative means greater than equal to 0. Okay, next, if the sum of, next point is, if the sum of 2 or more positive quantity, if the sum of 2 or more positive quantity, if the sum of 2 or more positive quantity equals to 0, then they all are equal to 0. How see this here? Means if the sum of 2 or more positive quantity equals to 0, then they all are equal to 0. How see this here? I am going to explain with example. Suppose I am taking here example like here root under u plus mod of v plus w square equals to 0. We know that this is a positive quantity, non-negative. This is non-negative. This is non-negative quantity, means we can say non-negative or positive. Okay, so this one is non-negative quantity. So what is the statement? If the sum of 2 or more positive quantity equals to 0, then they all are equal to 0. So when it is possible? It is possible when this value, if this value will take 0, this value will take 0, and this value will take 0, then it is possible. 0 plus 0 plus 0. Okay, how see this here? Suppose you can say in this way, sir, we can put in this way also, here 1, here minus 1, and here 0, 1 minus 1, 0, 0 plus 0, 0. Yes, you can put, suppose you are putting this one, it is okay, but here we know that this one is also a square, a square is a non-negative quantity, you can put this one. But what about this one? This is modulus of v, and we know that modulus cannot be negative. Okay, so this is not possible. Okay, that's why you can't take, only one possibility is there, 0, 0, 0. So we can put here 0, 0 and 0. So you can write directly here root under u equals to mod of v equals to w square equals to 0. This is your answer. Okay, our next point is suppose I am going to take one more example with the help of this. See this here, related to this statement I am going to take one more example here. See this, root under x minus 1 plus root under x minus 1 plus x plus 1 mod of x plus 1 equals to 0. Okay, now see this, we know that this is also positive, this is also positive. Okay, so what we will do, we have to put this one 0. So x minus 1 equals to 0, you will get here x equals to 1. Here what we are getting? We are getting here mod of x plus 1 equals to 0. So mod of x plus 1 equals to 0. Okay, so what you will get here? X equals to minus 1. So see this here, actually sum of this means sum of 2 or more positive quantity equals to 0, then they all are equal to 0, means this should be 0 and this should be 0, then it is possible. Okay, so here we are putting 0, so we are getting x equals to 1. Here we are putting 0, then we are getting x equals to minus 1. So at a time means no two value is possible. Here we are getting x equals to 1, here we are getting x equals to minus 1. So how it is possible? At a time two value is we are getting two value here of x. Okay, so this is not possible. No value of x is possible. No value of x is possible, or you can say no solution. Okay, now see this here. Simultaneously we are getting two values, that's why no value of x is possible. So see this next is formula. See this here, we know that for basic formula a plus b whole cube. What is the formula of a plus b whole cube? We know that a cube plus 3a square b plus 3ab square plus b cube. Okay, now see this here. If you notice one thing here, so you can say here degree of this is degree is 3 and terms are 4. How see this here? What is the degree of this a plus b? 3, means power of this is 3. So here how many terms? 1, 2, 3 and 4. Okay, so you can say from here you can say that means term is always 1 more than the degree. If degree is 3, so term is 4. Suppose I am taking here a plus b raised to the 4. So what is the degree of this here? 4. So terms will be 5. How see this here? A raised to the power 4 plus 4a cube b plus 6a square b square. Okay, plus 4a b cube plus b raised to the power 4. Now see this here, how many terms? 1, 2, 3, 4 and 5 terms. Means degree is 4 here, degree equals to 4. So we are getting terms are here 5. Means again you can say terms is always 1 more than the degree. If degree is 4, so terms is 5. If degree is 100, so terms is 101, means 101. Okay, but here see this here, actually a raised to power 4 a cube b, and one more thing you can notice here, means power of a is decreasing and the power of b is increasing. Here what is the power of a? Nothing is there, so you can write 0. Okay, so see this here, a power 3, here a power 2, a power 1 here, and here nothing is there, it means a raised to the power 0. What is the power of b here? 0, b power 1, b power 2, b power 3, means power of a is decreasing and power of b is increasing. Okay, now we are going to start, means one more example. See this here, one more thing we are going to discuss. See this here, that is very very important. If suppose if x belongs to minus 1 to -1 to 4, then find x square belongs to. Okay, this is our question. If x belongs to -1 to 4, then find x square belongs to. Now see this, it's very simple here. See this here, actually first of all we will draw the graph of x square. So we know that this is the graph of x square, this is y axis, this is x axis. Okay, this is the graph of x square. Now see this here, -1 you can take here first plus, then I will explain -1. Okay, so 1 to 4, if x belongs to 1 to 4, then find x square belongs to. Now see this, means what is the range of x square belongs to. See this is y equals to x square graph. Okay, now here what is the given? X belongs to 1 to 4, so this one is x equals to 1, this one is x equals to 4, x equals to 1, x equals to 4. So see this here, this is the input, x value 1 or 4. So corresponding to this, what we get here? Y equals to x square. Y equals to x square. What is x? 1. So 1 square. You will get here 1. Now corresponding to this, what we will get here? Y equals to x square. It means here what we will put here? 4. 4 is there, na? So 4 square. You will get here 16. So what is this is our area. See this, from here to here, this is our area. This is our part of the graph. This one. Okay, so x belongs to 1 to 4, so we can find in this way x square belongs to, what is the value of x square? See this here, answer of this is x square belongs to here 1 2 16. Okay, this is our answer. Now we will discuss with negative, means if x belongs to minus 3 to 4, minus 3 to 6, then what is the value? See this here. If I am asking here, suppose example, if x belongs to minus 1 to 4, same with negative, minus 1 to 4, then x square belongs to, what is the value of x square? See this here. Same as it is we are going to do here. See this here. We know that this is the graph of y, x square, y equals to x square, y equals to x square. Okay, this is x axis, this is y axis. Now see this here. What is the given input? Means x belongs to minus 1 to 4. So we know that this one is minus 1. This is here 4. Okay. So corresponding to this here, what will get? Y equals to x square. X square. What is x value? Minus 1. So minus 1 square equals to, you will get here 1. Okay. This one is 4. So corresponding to this, what will get? Y equals to x square. Y equals to x square means 4 square. So you will get here 16. Okay, now see this here. We are getting here 1, we are getting here 16. But what is the part? Actually, this is the part. It is starting from here to this. This is the area of our graph. Means minus 1 to 4 it is going. Okay, now see this here. Actually, we know that this is origin 0, 0, comma 0. So this graph is passing through the origin. So if you find this on this origin, so what you will get? Y equals to x square means 0 square, you will get 0. So what is the output? Output we are getting here answer 1, here we are getting 16, and one more thing, this graph is passing through the origin. So if you put 0 instead of x, then you will get y value 0. Means out of this 1, and if you put 0, so you get 0, and you will get here 16. So out of this, among these three, which one is greater? Which one is greater? X square belongs to, which one is greater? 16. 16 is our greatest value. Which one is minimum value? Minimum value is 0. So maximum value is 16, minimum value is 0. Okay. So in case of negative, always minimum value will be 0. Okay. So you can remember in this way. Next example I am taking, with the help of that example, this will be clear. See this here. If suppose x belongs to, I am taking another example. X belongs to, if x belongs to minus 4 to 5, minus 5 to 4, minus 5 to 4, then find x square belongs to. Now see this here. You can get idea from this. See this here. Again, x square means we have to find the value, means output. So this one is y equals to x square. So we are going to draw the graph of y equals to x square. So we know that this one is y equals to x square. Y equals to x square. What is the input given here? Minus 5 or 4. So we know that this one will be minus 5 here, and this one is here 4. Okay. So corresponding to this, minus, this one is actually minus 5. Okay, and this one is here 4. Okay, so corresponding to this, this is the x value. So we know that this is the graph of y equals to x square. So if you put this x value here, so what you will get here? 16. You will get here 16. Now see this here. If you are going to substitute this value 5, so what you will get here? Y equals to minus 5 square means you will get here 15. Sorry, 25. Okay. You will get here 25. Now see this again, but what is our part? See this here. Actually, this is the part of our graph. This is the area of our graph. So see this. Actually, again, same thing. This graph is passing through the origin. Okay. So corresponding to this minus 5, we are getting 25. Corresponding to this 4, we are getting 16. We are getting here 16. We are getting here 25. But corresponding to this, what we will get here? Y equals to 0 square. Means you will get here 0. Okay. Now see this here. What we are getting output? Output we are getting here. Actually, we are getting 3 output. 25. Corresponding to this 4, we are getting 16. Corresponding to 0, we are getting 0. Now see this. Out of this, which one is maximum and minimum? X square belongs to. Which one is maximum? Maximum is 25. So our next heading is classification of number. Okay. So first is natural number. First is natural number. Okay. So what is called natural number? We know that all counting numbers are called natural number. All counting numbers are called natural number, okay, and it is denoted by capital N. Okay, now we know that all counting numbers are called natural number, means it will start with 1, 2, 3, 4 and so on. Okay, so this is called natural number. Okay, it is denoted by capital N. Now second is whole number. Now see this, what is called whole number? All counting numbers are called natural number. So what is called whole number? Natural number including 0, means if you include 0 in natural number, then it will become whole number. Natural number including 0 is called whole number, and it is denoted by capital W. Okay, now see this here. What is called natural number? All counting number are called natural number. Okay, and it is denoted by capital N. Okay, so it is just starting from 1, 2, 3 in this way. Now in the same way, what is called whole number? So for whole number, natural number including 0 is called whole number, and it is denoted by capital W. So it will start with 0. Natural number starting with 1, so it is starting with 0, 1, 2, 3 and so on. See this is a natural number, and when we are including this 0, so it is becoming whole number. Okay, so our next point is point number third is natural number, whole number, after that integers. Okay, actually we know that in the numbers, integers, the numbers -3, -2, -1, 0, 1, 2, 3 and so on is called integers. It is denoted by capital I. Okay, so numbers will be like this, plus minus 3, or you can say plus minus 3, plus minus 2, plus minus 1 or 0 in this way. So minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, and so on. This is called integers, or you can say in a simple word, a number which is not a fraction, that is called integers. Okay, so our next point is prime number. So what is called prime number? What is called prime number? Prime number. What is called prime number? Number which are divisible by divisible by 1 and itself. Okay, what is called prime number? Number which are divisible by 1 and itself. So what is the meaning of this series? I am going to take example here. 2 is a prime or not? Yes, 2 is a prime number. Why? Because this 2 is divisible by 1 and itself. 3 is a prime? Yes, 3 is a prime also. Why? Because 3 is divisible by 1 and itself. In the same way, 4 is prime? No, 4 is not a prime. Why? Because see this here, 4 is divisible by 1, 4 is divisible by 2, and this 4 is divisible by 4 also. So 3 factors here. But the condition of prime number is number divisible by 1 and itself only. Okay, so 4 is not a prime number. 5 is prime number? Yes, 5 is a prime number because 5 is divisible by 1 and itself. Okay, this 3 is divisible by 1 and 3, this 2 is divisible by 1 and 2. Okay, in the same way 7, 9. Okay, so 9 is also not a prime. Why 9 is not a prime? Because this 9 is divisible by 1, this 9 is divisible by 3, this 9 is divisible by 9. Okay, so because of this 3 it is not possible. 11, yes, 11 is prime. Why? Because 11 is divisible by 1 and itself. 13, 17, 19, Okay, so in this way these all the numbers are called, these all the numbers are prime number. Okay, so one is prime or not? One is neither prime nor composite. We will discuss this. Now next here, composite number 5. Composite number. What is called composite number? Number having more than 2 factor, number having more than 2 factor, more than 2 factors are called composite number. Composite number. What is the definition? Number having more than 2. Okay, more than 2 factors. Okay, number having more than 2 factors are called composite number. Or one more definition is there. You can say in a simple word, number which is not a prime, is called composite. Means another definition of composite is number which is not a prime. A number which is not a prime, that is called composites. Okay, now see this here. I am taking here example. What is the example of composite number? 2 is a prime. 4 is a composite number. Yes. How? See this. 4 is divisible by 1. 4 is divisible by 2, and 4 is divisible by 4. What is the first definition? Number having more than 2 factors. So 4 has more than 2 factor or not? Yes. 1, 2 and 4. Yes, this is a composite. If I am asking 6 is a composite number. How? See this here. 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, and 6 is divisible by 6. Yes, this is also composite because more than 2 factors. See this, 1, 2, 3, 4. 4 factor is there. That's why this is a composite number. I am asking 8. 8 is a composite. How? See this, 1, 2, 4 and 8. These are the factors of this 8. Means this 8 is divisible by 1, 2, 4, 8. That's why this is a composite number because it has more than 2 factors. 9 is a composite. Yes, 9 is a composite. Why? This 9 is divisible by 1, this 9 is divisible by 3, and this 9 is divisible by 9. So more than 2 factors. That's why this is composite number. Or you can say in a simple word, number which is not a prime is called composite. See, this 4 is not a prime, 6 is not a prime, 8 is not a prime, 9 is not a prime, 12 is not a prime, 16 is not a prime, 15 is not a prime. The number which is not a prime, that is called composite number. Okay, one more thing here. One is composite? No, one is neither prime nor composite number. Okay, we will discuss later. Now see this here. Next is twin prime. Next is twin prime. 6 number, twin prime. Twin prime number. What is called twin prime? See this here. 2 prime number. 2 prime number. 2 prime number if 2 prime number if 2 prime number is said to be twin prime, is said to be twin prime. Okay, if their difference is 2, if their difference is 2. See this here, twin prime, 2 prime number, twin prime. So twin prime is 2 prime number is said to be twin prime if their difference is 2. If their difference is 2. For example, I am taking an example like 3, 5. Yes, both are prime. This is prime, this is prime, and their difference should be, both numbers should be prime number and their difference should be 2 here. So this 3 and 5 both are prime and their difference is 2. Yes, this is a twin prime. I am saying here 5 and 7. Yes, this is a twin prime. Why? See this here, 5 is a prime, this one is prime, both are prime, but their difference is 2 here. I am asking 11, I am asking 11 and 13 is a prime, twin prime or not? Yes, this is also twin prime because this is a prime, this is a prime, and their difference is 2. Okay, so now I am going to discuss co-prime number. Co-prime number 7. Co-prime number. See this here. Or you can say co-prime, or you can say relatively prime. Relatively prime, or one more name is there, you can say mutually prime. Mutually prime. Co-prime you can say relatively prime, or you can say mutually prime. Okay, so what is co-prime? Co-prime. Now see this here. Co-prime or relatively prime, or you can say mutually prime. So what is co-prime? See this. If two natural number, if their difference, if their HCF, if their HCF is 1. Two natural number, if their HCF is 1. Okay, means two natural number is called co-prime. Okay, if their HCF is 1. This is the condition. Okay, this is important condition. If their HCF is 2. So see this, I am going to take example for this. This is a twin prime. I am asking here, like two natural number, if their HCF is 1. So see this, 2 and 3. Yes, two natural number. Yes, 2 and 3 is a natural number, and their HCF is 1. Yes, 277. Yes, this is a natural number and their HCF should be 1. Yes, if you check the HCF of this, you will get 1. So their HCF is 1. Means what is called co-prime or relatively prime or mutually prime? It's very simple. Two natural number is called co-prime, or you can say relatively prime, or you can say mutually prime if their HCF is 1. So see this, if you check here, HCF of this is 1. Here, what is the HCF of this? Is 1. Okay, now we are going to discuss. Next is some important note here. Some important note. See this here. First note is 2 is the smallest even prime number. Note. Some important note is there. First note, 2 is the smallest even prime number. Smallest even prime number. First point. What is the second point? Second point is 4 is the 2 is the smallest even prime number. 4 is the smallest composite number. Composite number. Okay. Next point is important. 1 is neither prime. 1 is neither prime nor composite. Nor composite. Okay, so see this note. 2 is the smallest even prime number. We have already discussed. 4 is the smallest composite number. Okay, and 1 is neither prime nor composite. So this is very, very important. 1 is neither prime nor composite. Okay, so you need to remember this. This third point is very, very important. Now we are going to start rational number. What is called rational number? What is called rational number? See this here. What is called a rational number? Now see this here. We know that actually this rational is made up of ratio. Rational is made up of ratio. This rational is made up of ratio. Okay, what is the meaning of rational number? Number which can be expressed. Number which can be expressed in P by Q form is called rational number. Okay, rational number. But some condition is there, and P by Q and P and Q should be integer, belongs to integer, and Q is not equal to 0. This is very, very important. Means rational number is actually like this, P by Q, where where PQ belongs to integer and Q is not equal to 0. This is very, very important. Now see this here. P by Q, where PQ belongs to integer and Q is not equal to 0. But the question is that why Q is not equal to 0? If you put here Q equals to 0, then 1 upon 0, it will not define. Okay, so P by Q, it should be in form of P by Q, where P and Q belongs to integer and Q should not equal to 0. If you put here 0, then it will not define. Okay, so our next, but actually the thing is that if like 1 by 2, 1 by 3, 3 by 2, it is given in this way, so you can identify easily. But if it is given in the decimal, so you can't identify. So see this here, I am going to discuss with another example. See this here, or another definition of this. After decimal, terminating or RNT. What is the meaning of RNT? Terminating. See this here. After decimal terminating means if a number, after decimal if a number is terminating, so we can say this is a rational. Or after decimal if a number is RNT, RNT means repeating with non-terminating. Repeating with non-terminating. Okay, now see this here. Repeating with non-terminating, then it is called rational number. Now see this here. How? See this. I am going to take example here. 3 by 2. 3 by 2 is a rational number. 3 by 2 is a rational number, P by Q form, and Q is not equal to 0. Okay, but if it is given in decimal form, so it, how can we identify? See this. What is the decimal of this? 1.5. See this here. After decimal, this number is stopping or not? Yes, see this. After decimal, this number is terminating. Okay, so this is rational. This is irrational because the condition after decimal, if a number is terminating, then this is rational. 2 by 3. 2 by 3. What is the value of 2 by 3? 0.6666 in this way it is going. 0.66. So if you notice this, so this after decimal, this 66 is repeating, so this number is repeating. Okay, so we can say this is RNT, means repeating with non-terminating. See this now, this 66 is repeating and it is not going to terminate here. Okay, so repeating with a non-terminating RNT, so we can say this is also rational. Okay, so I hope you are getting this. Means after decimal, if a number is terminating or if a number is repeating with non-terminating, then it is called rational number. Now we are going to start irrational number. Okay, and one more thing, this rational number is denoted by capital Q. Means this rational number is denoted by capital Q. Now we are going to discuss irrational number. Irrational number. So it is denoted by Q dash, or you can say Q bar. Okay, and rational number is denoted by Q only. Okay, so what is the definition, basic definition of irrational number? Number which cannot be expressed. Number which cannot be expressed in P by Q form. Simple. A number which cannot be expressed in P by Q form, that is called irrational number. Okay, but the thing is that if it is given simply, so we can identify, but it is given in decimal form, then how can we identify? So simple. See this here. Or another definition, after decimal, NRNT. What is the meaning of NRNT? Non-repeating, non-terminating. Actually, NRNT means non-repeating, non-terminating. Means after decimal, if a number is non-repeating or non-terminating, then we can say that is irrational number. How? See this here. I am taking here some example here. What is the value of root 3? Root 3 value we know that 1.732050. okay, at 0 7. In this way it is going. Okay, so see this here, this number is irrational or not. We know that already, we have already studied root 3 is a irrational number, but if it is given in decimal form, so how can we identify this is a irrational or irrational? So we can identify, see this here, after decimal NRNT, non-repeating, non-terminating. So see this here, this number is repeating or non-repeating? Non-repeating. All number are different. Okay, and this is terminating or not? This number is not going to terminate. So this is follow this condition, NRNT, non-repeating, non-terminating. All number are different and it is going, and it is not going to terminate. So NRNT, that's why it is called irrational number. Okay, irrational number. What is the second example of this? Second example is this is pi. I am taking pi. Pi is a rational or irrational? Irrational number. What is the value of this? 3.14159265. In this way it is going. Okay, now see this here. This is a irrational or rational? Irrational. How? See this here. After decimal, if you notice this one, so you can say this is non-repeating. All number are different and non-terminating. Yes, it is not going to terminate. So that's why it is again same. It is following this condition, NRNT. So we can say this is irrational number. After decimal, NRNT, non-repeating, non-terminating. Okay, now next, what is the next? E. What is the value of E? So E value, we know that E means exponent. So what is the value of this? 1.71, 8, 2 at 1, at 2 at 4, 590. In this way it is going. Okay, so now see this again, if you observe this one here, after decimal these numbers, so you can say this is NRNT. How? After decimal this is non-repeating, non-terminating. All number are different and it is not going to be terminate. So it is following NRNT. Okay, so we can say this is again irrational number. Okay, irrational number. Okay, so I hope you are getting this. If a number is given and after decimal, if a number is like a non-repeating, non-terminating, NRNT, so we can say that is irrational number. Now we are going to discuss some important note here. Some important note is first is 22 by 7 and pi, which is rational and which is irrational number. See this here. Note. I am asking here 22 by 7 and pi. Okay, we know that 22 by 7 is rational number. How? P by Q from simple. P by Q from Q is not equal to 0. So we can say this is a rational number. Rational number. What about this Q? Q is a irrational number. Now we have studied, means pi is a irrational number. Okay, both are equal or not? No, both are not exactly equal. They are next to each other. Both are, these are not exactly equal. Exactly. So you can say we have already studied in 9th, 10th, means instead of pi we have taken 22 by 7. Yes, okay, but actually for calculation purpose we have taken, but exactly both are not equal. Both are not exactly equal. They are next to each other. So we can't comment about anything which one is greater here. So they are not exactly equal. These are not exactly equal. These are next to each other. Next to each other. Now we are going to, so I hope you are I hope you are getting this. Means 22 by 7 is rational, this is irrational number. Okay, and these are not exactly equal, both are next to each other. So our next heading is real number. Next heading is real number. Next heading is real number. See this here. What is called real number? We know that real number is denoted by capital R. Okay, so what is a real number? Set of all rational and irrational number. Set of all rational and irrational number are called real number. Okay, and it is denoted by capital R. Set of rational or irrational. What is the meaning of this? See this. I am going to explain here. This is very, very important here. This one, rational and irrational. Set of rational or irrational. You can write in this way. R is the, it is denoted by R, or you can say R is equals to set of rational and irrational number. Irrational number is q dash, rational or irrational number. Okay, now see this here, this is number line. Okay, this one is 0. If you move towards right side, then you will get positive number. If you move towards left side, then you will get negative number. Okay, now see this here. Now see this. Now we know that what is the value of root 3? Root 3 is 1.7320 in this way. So 205080 in this way. So see this, root 3 value is 1 point something, means it is sure that it will lie between 1 and 2. So here I am writing root 3. Okay, what is the value of pi? Pi value is 3.1415 in this way, means 3 point something, means less than 4 and greater than 3. So pi will lie here. So we know that this minus 3, minus 2, minus 1, 0, 1, 2, these all numbers are rational number, but root 3 is a irrational number, pi is a irrational number. So see this, we can say, and this one is the real axis. So we know that, so we can say that real number, this is the set of all rational number, and irrational number, this is irrational. This is irrational number. Okay, and one more point you can write here, lying on x-axis. Lying on x-axis. Okay, so I hope you are getting this. Now one more thing which is very very important, I am going to write in note. We will write in note, we are going to write, see this here, note, this is very important. See this, we know that complex number is divided into two parts, real and imaginary. Now we know that real number is divided, it is the set of rational and irrational. Okay, rational, so I am writing a q. Okay, and here I am writing q dash, irrational. Okay, and this rational is the set of, rational can be integer or non-integer, I dash. Okay, and this integer can be like this positive integer or positive integer I plus 0. Okay, here I minus, okay, non-negative, sorry, this one is integer is divided into two parts, means it can be positive integer, negative integer or 0. Now see this here, now see this complex number. So can I say right here like z means complex number. This is superset of this real number. Okay, and this real number is a superset of this rational number. Rational number is a superset of this integer, and integer is the superset of this, integer is the superset of whole number, and whole number is superset of natural number. How see this na? Actually this is a positive integer, so this is, we can say this one is a natural number. Okay, and if you include this 0 in this natural number, if you include in zeros, so what you will get? You will get whole number. Okay, so this thing you need to remember here. Okay, so I hope you are getting these all the things.